Okay, we need to look at a few things on your calculator just to make sure that they're working for you. If I ask you to find the cosecant of 220 degrees, most calculators will do that without messing with reference angles. Some of the older calculators would not, and you'd have to figure out the reference angle, but just get your calculator out and make sure that this works for you. So remember that the cosecant, and you don't have a CSC button on your calculator, but remember that the cosecant is 1 over the sine. So the cosecant of 220 degrees is 1 over the sine of 220 degrees. So in your calculator, you need to find the sine of 220 degrees, and then you have two options. There is either a button on your calculator that says x to the negative 1. That will take the quantity and find its reciprocal. Or you can take this answer and take 1 divided by the sine of 220 degrees. Now, you all have different calculators, so I can't tell you specifically how this is going to work. But see if you can do that and get the correct answer. Okay, now you should get negative 1.5557. For the next one, cotangent of negative 230 degrees, well, that's 1 over the tangent of negative 230 degrees. You should have a calculator button that looks like this. It's not the subtraction sign, it's the negation sign, so that you can put a negative in front of your 230. So 1 over the tangent of negative 230 degrees should be negative 0.8391. Now if you're not getting those numbers, you need to see me sometime so that I can help you with your calculator. Okay, it's time we move on. We're going to look at radian measure. Now, radian measure is just another unit. Instead of, like, if we measure a length of something, we can measure it in inches or feet or centimeters or meters, and those are all valid units of measure. There is another way that we measure angles other than just degrees. We can measure angles in what are called radians. So the measure of an angle is determined by the amount of rotation from the initial side to the terminal side. And as long as the vertex of the angle is at the origin, it is called a central angle because its vertex is the center of the circle. So now here's what we need to look at. 1 radian is the measure of a central angle that intercepts an arc S equal in length to the radius r of the circle. So let me show you what that looks like. If I have a circle, radius is 10. If I take a piece of string that's 10, let's say this is 10 inches. If I take a piece of string that's 10 inches long and I lay it along the outside edge of the circle so that this length from here to here is also 10. This is called the arc length because it's the length of the arc. If the radius is the same as the arc length, which means if I take the radius and I lay it along the edge of the circle, the size of this angle from here to here, the size of this angle is 1 radian. So how many radians are in a circle? Now I'm going to use just a generic r instead of 10, but if you want to think 10, that's fine. Whatever this length is, I'm going to piece a string down here that's the same length. And I'm going to put another piece of string that's the same length, all the way around the circle. So what that means is every time this length is the same length as the piece of string, this angle right here is 1 radian. So if I put this angle with my theta, that would be 2 radians. 3 radians, 4, 5, 6. So it looks like I get 6 radians and a little bit more, about a third more. I've got all the angles marked here, and it looks like I get 1, 2, 3, 4, 5, 6 radians, but then I have just a fraction of a radian. That doesn't seem like it's a really good idea, because like when we do degrees, we get 360. It's a nice whole number. Now I've got 6 1/3 radians. That seems a little bit weird. But let's keep going and see what happens. Okay, we know the circumference of a circle is 2 pi r. Okay, so remember what r stands for? When you're talking about circumference, r stands for the radius. But on the picture we just had here, r also stood for those little pieces of string that I put down all the way around the circle. Each of those r's represented a radian. So if the circumference of the circle is 2 pi r, that means I've got 2 pi radians in a full rotation of the circle. Okay, now we know that pi is about 3.14, so 2 times pi is about 6 and 2.28. That matches what we found above. Remember it was about 6 1/3 radians? Well, it's not about 6 1/3, it's exactly 2 pi radians. So if a circle contains 2 pi radians, then half of a circle is pi radians, and a quarter of a circle is pi over 2 radians. So if you look at the unit circle here, or actually any circle, this angle here is 1/6 of the semicircle. If you think of it in terms of a fraction of the semicircle, here's a semicircle, and from what I said before, if the entire circle is 2 pi, a semicircle is pi radians. So this is 1/6 of pi. 1/6 of pi can be written as 1 pi over 6 or just pi over 6. If you look at this one, again, here's the semicircle, that's pi. We're looking at 1/4 of it, so pi over 4. This is 1/3 of the semicircle, so that's pi over 3. This is a quarter, so that's pi over 2. Here's the semicircle, that's pi, and an entire rotation is going to be 2 pi. Now a degree is 1/360th of a circle. So we know that there are 360 degrees in a circle, and there are 2 pi radians in a circle. So what that means is 2 pi radians equals 360 degrees. Well, let's see what that does for us. If I take this and split each of them in half, that would mean 1 pi radian equals 180 degrees. It also means if I take both of these and divide through by 360, I get this equation. 1 degree equals pi over 180 radians. Or if I take this equation and I divide both sides by 2 pi, like this, then I get 1 radian equals 180 over pi. So these are this is the way to link the two together. The degree is pi over 180 radians, and a radian is 180 degrees. You can probably guess what's coming here. We're going to have to be able to convert radians to degrees and degrees to radians. So for example, if I have pi over 2 radians. Do you remember where that was on the unit circle? Well, let's find out. If I have radians and I want to change it to degrees, I'm going to multiply by 180 degrees over pi. What happens here is the pi's cancel, and 180 divided by 2 is 90 degrees. Or let's say I want to change, let's do 30 degrees. I want to change that to radians. I'm going to multiply by pi over 180. If I look at this fraction, if I multiply it, I get 30 pi over 180. We'll simplify that. 30 goes in here once, 30 goes in here 6 times. That equals pi over 6. The way that I remember is if I have degrees, there's usually no pi listed. Radians usually have a pi. So if I've got degrees and I want to change the radians, I'm going to need a radian, I'm going to need a pi on top. So I multiply by pi over 180. If I'm going from radians to degrees, I want the pi's to cancel. So I put the 180 over pi. So you can either just memorize this or just kind of think through how it works. But you need to be able to go between one and the other. So I'm going to put up an example and I want you to pause the video and see if you can work it out. Convert 120 degrees to radians. Pause the video and work that out. If you take 120 times pi over 80 and simplify the fraction, you get 2 pi over 3. Okay, let's do another one. Convert negative 315 degrees to radians. Now when you do this, don't worry about the minus sign or the negative, just do the 315 degrees and then put the minus on, because remember the minus only means the direction of rotation. Multiply by pi over 180, simplify the fraction, and you get negative 7 pi over 4. Okay, let's do one more. Okay, pause the video and convert 5 pi over 6 to degrees. And your answer is 150 degrees. I want to look at one more because this might catch some of you off guard. Convert 7 to degrees. Now, this doesn't have a pi in it, but it is still radians. If you have an angle measure that is in degrees, it must have the little degree symbol. So this is actually radians, 7 radians. So radians to degrees multiply by 180 over pi. If you put that in your calculator, you get 401.07 degrees. Now that makes sense because remember that it took 6 1/3 radians to get all the way around the circle, which is 360 degrees. Well, this is a little more than that. So you'd expect it to be a little more than 360 degrees. Okay, so you could probably guess what's next. We need to take all of our degree measures and match them up with the radian measures. Now when I look at the radian measures, I try and look at how they work out with the actual angle measures, because this is 30 degrees, but if I look at the fractions, this is 1 pi over 6, this would be 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. So if I look at just the 30-degree angles, if I count in 6, I go 1, 2, 3, 4, 6, 5, 6, 6, 6, 7, 8, 9, 10, 11, 12 sixths. And obviously we're going to simplify the fractions when we can. And you're going to do the same thing with the other measures. When I look at the 45 degrees, I count by fourths, because remember this is 1/4 of the semicircle. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. So if you think of this in fourths, you're going to have 8/4 all the way around the circle. Okay, let's look at the pi over 3 angles. Okay, pi over 3, that's 1/3 of pi. So now we're counting thirds. There are 3 thirds, so 1/3, 2 thirds, 3 thirds, 4 thirds, 5 thirds, 6 thirds. These are the pi over 3 angles, and it's cutting the entire circle into thirds, 6 thirds altogether, because remember from 0 to pi is 1 pi. So this is in thirds. And then finally for the quadrantal angles, this is 1/2 of the semicircle, this is 2 halves, this is 3 halves of the semicircle, 1, 2, 3, 4 halves. So if you think of the radians as being fractions of the semicircle, I think it will help you get things in the right place. Okay, so here's the final dance. you need to memorize the entire unit circle, not only the degrees, but also the radians and the coordinates. So anything I ask you, if I say, what's the sine of pi over 4? You should be able to come over and pick out, here's pi over 4, the sine is the second coordinate, sorry. So it'd be radical 2 over 2. I could come say, okay, what's the cosine of pi? You go to pi, which is over here, and the cosine is the x-coordinate. I can say, what's the sine of 120 degrees? So you find 120 degrees, the sine is the x-coordinate, and so forth. So you need to have this memorized, and that's why that's the only job you have to do for day 1 of your assignment is to memorize the unit circle. So there are copies of what you see in front of you in the Overhead Masters. There's a blank one. Print some and work it out, and work so that you can reconstruct the unit circle. And I think that'll do it. So have a good week, and we'll see you next week.